Hello and welcome to Living Outside the Matrix, the podcast where we challenge assumptions and do a little bit of independent thinking and try and step outside the box a little bit. Hi there, I'm your host, Nigel Howitt, and on the show today it's my very great pleasure to be joined by Dr. Zach Bush from Virginia in the States. On the show today we're going to be taking a deep dive into the whole sort of paradigm shift that I think many people are aware is occurring within healthcare and people in pursuit of health in general. So Dr. Bush is a very qualified doctor in the United States. He's triple board certified, and he has experience in internal medicine, endocrinology and metabolism, as well as palliative care. And he's also an internationally recognized educator on the microbiome and nutrition. He and his team have discovered some profound new insights into human health and in gut health and the interrelation between the two and how they affect longevity and such. So Dr. Bush, a very warm welcome to the show.
Nigel, so glad to be here. I appreciate it.
Great. So Dr. Bush, maybe you could kick us off with a little bit about yourself just to start off, and then we'll try and get into the story of this paradigm shift that's going on.
Sure. My background is actually in allopathic medicine, just Western medicine training. I did my training out in the University of Colorado, and then got interested in neuro health, specifically the relationship between the endocrine system, or the hormones, and the way it regulates our brain, and what happens as our brain shifts as we move into depression and other mood disorders. And so that was my initial research interest. Got involved with a gentleman at the NIH named Philip Gold back in the 1990s, looking at these topics, and then that kind of morphed into my career at the University of Virginia, where I studied internal medicine and moved on to be a chief resident or do a teaching faculty year after that 3-year residency, and really dove into the educational realm much more thoroughly that year, and really got hooked on the joy of teaching and the joy of watching med students get excited about knowledge, and residents as well. And that experience really accelerated me. But by the time I was practicing medicine after that, I was realizing that what I was teaching was not really sticking. We were not seeing the results and the patient outcomes that we would expect from the science that the pharmaceutical companies had handed us to say, hey, this is how these drugs work, this is how it's going to improve the health of your patients. Really didn't see that coming to fruition. In fact, I saw my patients really declining really steadily over the years of my care, and a lot of it really had horrible outcomes. I had young people with mood disorders that were committing suicide. I had diabetics that were getting more diabetic, more obese with every single medication I started them on. It was just, I felt like I was part of their slippery slope towards decline as a doctor, and that was really flying obviously to the opposite of what I had expected to be able to achieve through that. And so I dove back into training with endocrinology and metabolism, and that was more study of the hormones and the regulation of the human system, the metabolism, looking at how we burn or store calories. And obviously it was right at the beginning of this huge obesity epidemic of the 2000s that we saw happen, and all of that. And so that was kind of my clinical side. And then as my endocrinology progressed, I got interested in tumors, and specifically endocrine tumors of the glands of the endocrine system. And that progressed to the point where I was starting to develop chemotherapy compounds for these tumors. And so that was kind of my march through Western medicine. And in that time really realized, boy, nothing is really getting at the root cause of anything. The startling realization as somebody who's designing chemotherapy is there's not a single cancer on earth that's ever been caused by a lack of chemotherapy, right? And so that sudden realization of, wow, we're just throwing symptom management or band-aids at diseases that are rooted somewhere completely different than where our toolbox lies. And so that realization really was a major paradigm shift for me, and I started to realize that I was going to have to really retrain myself in the sciences that I knew, and really start to look for new tools to put into my toolbox. And we had an exciting kind of burst of information coming out in the late 2000s from UCSF, University of San Francisco, University of California, San Diego. Out in these California programs, we were starting to see ripples or tremors of new information saying that the microbiome, or the bacteria in our gut, was predicting what cancers people would get. And for a cancer researcher, this was a complete disconnect. This was coming out of left field completely, with this realization that what if cancer is not even rooted in the human cell? What if it has something to do with non-human cells? That was just such a huge, confusing shift. To this day, if you go to the American Cancer Institute or something like that, they define cancer as the most common genetic disease in humans. Well, first of all, it's not genetic, because you can't have an epidemic of a genetic disease. Second of all, we now have 10 years of data that says, yes, that it's not, the root cause of cancer has nothing to do with the human cell at all. So the stagnancy of Western medicine in that pharmaceutical environment continues to be quite striking, and it's the reason we aren't seeing great advances in cancer management, right? We actually are accelerating our rates of cancer death, not slowing them down. And so that paradigm, like you said, of kind of this collapse of human health that's happening around us, is really part and parcel to the fact that the training of the physicians and nurse practitioners and PAs and all of those people that you would expect to be equipped to help you achieve health, we're not. We are equipped to actually manage your disease and kind of slow down perhaps, or change the trajectory of your disease, but we're not there equipped to actually tell you how to be healthy or how you might actually reverse that disease. Yeah. And so that was kind of my journey and my background, if that gets you there.
Absolutely. So so we can start to see that shift you mentioned around about the early 2000s, the sort of discovery of a correlation between profiles of gut bacteria and different diseases, and I suppose before that there was also the concept of epigenetics, wasn't there, that sort of started to shift things away from the allopathic model. Was that causative, do you think, in that?
Absolutely. In the 1990s, when I started my pre-med training in medical school, there was these promises being put out there that, look, we're just starting to decode the entire human genome. By the time you're a full-fledged doctor, by the time we're in 2002, we're going to have, a simple thing where you spit in a cup and we'll run your entire genome. We'll tell you exactly what diseases you're going to get. And we'll tell you exactly what treatments are going to be there. We had this belief that the human genome was this fixed predictor of your health. And what happened was a startling scientific discovery that's really never gotten any press time because it's so ridiculously paradigm shifting that nobody really wants you to know this, in the sense that it changes the whole worldview of who you are. You only have 20,000 human genes. That might sound like a lot, but you have over 200,000 proteins that are made by those 20,000 genes. That was very confusing. But the scale of this genome at 20,000 genes was so tiny compared to what we expected, because we had already decoded the genome of the flea, that little insect that can leap 40 times its height and all of that. That flea has 30,000 genes. You're only 2/3 as complicated as a flea genetically. And this I use as kind of my backup. Like if I'm having a rough day and I can't find my keys and kids are not in the place they need to be, or I miss my airplane flight, I just tell myself, I'm only 2/3 as complicated as a flea. I'm doing pretty good. So this field had to shift at that point. We had to say, okay, how is it possible that a tiny little genome of 20,000 human genes could possibly predict or code for this extraordinary complexity of the 70 trillion human cells that build a human body, subspecialized into all these things, communicating across these systems. And so that birthed the industry, or the science of epigenetics that you mentioned. But this was really still falling short of answering a lot of questions. Epigenetics is the phenomenon where your environment, the air you breathe, the food you touch, all these things can methylate or change the promoter region of a gene. This can actually lead to a situation where a gene can't turn on or a gene does turn on. But we were falling far short just by the simple methylation patterns of being able to describe how does a single gene turn into 200 different proteins. What is that level of nuance from? And that story actually stayed unanswered for almost 18 years. And it was really not until the last 3 or 4 years where the answers really started to come out that it's actually the non-coding sequences in your genome that are making the on-off switches and the nuance switches that determine the behavior of your mere 20,000 genes. That field is now called microRNA, and so microRNA are these tiny little peptides or these proteins that are made from the surface of or from the non-coding regions of your DNA, which is the majority of your DNA.
Okay, and can I just interrupt you? So that control over our genetic expression, that's coming from this region of our DNA you just said. Is it also coming from the environment? It's kind of a mixture of the two, is it?
Stunningly, you're exactly right. So it turns out that these non-coding regions of DNA in the human genome, this is a huge percentage, 99%. 99% of your genome does not make a gene. What? That's totally bizarre. Yeah, that was another unexpected finding, is that 1%, maybe 1.5% of the human genome, all of the DNA in your body, actually codes for a gene. The rest of it was called junk DNA, because we couldn't figure out what the heck it was doing. What's the likelihood that nature designed you with 99% junk and 1% purpose? It's just not possible, right? And yet that's the mentality of the science world as well. We can't figure it out. It's probably leftover junk from evolution was literally the description that remains today. If you read a journal on microRNA and junk DNA, it's thought, well, that's just leftover junk from you evolving from a single bacteria to the human you are today. Well, it turns out that those microRNA coding from the 99% of your genome, they're that nuance adjustment, and they can travel. And so this is much different than the methylation process, and the epigenetics is controlled at the cell level. And so environment happens to the cell, and it changes its methylation epigenetics pattern. The microRNA, in contrast, are moving all over the body. Okay. In fact, they're leaving the body. And this is striking. This is really important for you if you're struggling to make lots of health changes in your life and you're not seeing the outcomes. Think about who else is in your immediate environment. Are they making the same health adjustments that you are? If you're plateaued and stuck, it's possible that their genome, that of your spouse who is still sitting on the couch and watching football or cricket on the weekends, you're not making progress because they won't change their environment. Their microRNA is still coding for a stressed out, poor health, poor nutrition genome or genetic decision making, and so you're stuck. But it goes beyond just their junk DNA and your junk DNA talking through the microRNA. It actually is the bacteria and the fungi and the viruses and the food itself. Wow. Because think about a soybean or a piece of corn, or more terrifying, a piece of beef. That meat or that vegetable has DNA, just like any other cellular organism. That DNA also has quote-unquote junk DNA that will then make microRNA. And the microRNA can travel. And we now know, and this is just the very beginning of this field still, but already we have found that at least 35 to 40% of the microRNA circulating in your bloodstream right now is not human.
Wow.
It's from bacteria, it's from fungi, it's from viruses, it's from the food you eat. This is really an interesting shift in our understanding of our relationship to the environment, isn't it?
Yeah.
Wherever we've thought, here's nutrition, here's milk, or here's a hamburger. It has these macronutrients. It has B12 because it's beef, or whatever it is. That's such a tiny little piece of what food actually is. Food, I think, is really not just a nutrient delivery system. It's a genomic download from your environment.
That's awesome.
It's a genomic download that's programming your DNA to make who you are today.
Wow, so you've got the food impact, as you say, and you've also got the impact of everybody else you live with, literally on their breath, emanating from their bodies. The effect is the environment, in a really holistic sense, then, I guess.
Yes, it is, and you can see what's happening as a society is we accelerate each other's stress. Right?
Okay.
And so if as a society we start to build structures and environments that are stressful, well, one stressed out organism putting out stress microRNA is going to code for a bunch of other stress in the environment. So picture how we raise our cattle or pork, or even worse, the poultry. And so the chickens and the turkeys that are packed into these, feeding centers that
Shocking.
are, a third of them are dead by the time they're 6 weeks old. And so it's so toxic, the food environment that we raise these animals in. Can you imagine the microRNA? Can you imagine the genes that are turning on in a chicken or a pig that is such a sentient being and is stuck in a confinement of 4 feet for its entire year of life, and then it's slaughtered in a stressed out, sick, dirty environment with just filth all over it? That animal is screaming for help and desperation and just panic at the DNA level. And then you go and put that piece of bacon in your mouth, and it's got DNA in it that's screaming, help, I'm desperate, I'm stressed out, I'm just barely hanging on, I need to store fat. Wow, you just turned on all of your own stress genes. You're responding to that stress environment. It's a disaster on a level that we could have never really predicted, I think, just how slippery a slope this was as we created the factory farming environment. And we did create that, which is good news on the sense that we can also change it immediately, right? Yeah. It's easy to kind of throw rocks at Monsanto or these chemical companies and say, well, it's their fault for making Roundup, or it's their fault for making chemical fertilizers and antibiotics. Well, not really. It's we stopped raising our own animals. We stopped gardening in our backyards. We started going for convenience lifestyles where we never even touch the soil, let alone the crop that grows in the soil. Absolutely. We're just waiting for that, clean, washed piece of corn or fruit or vegetable. Certainly you guys historically in Europe have been slower to adopt this environment, but you're way beyond adoption at this point. England is absolutely buried in GMO crops, just like we are now. So while there was a hesitancy, if you look at just like the antibiotic usage worldwide in animal production, Greece is number 2 behind USA. What? Like, that's unexpected. Yeah. Norway's up there. Like I think number 3 is like at least recently the Netherlands were number 3 or number 4 in the usage of antibiotics in feed crops. And so you just start to realize, wow, there's really no country that's clean anymore. We're just buried in this stress environment of food production.
Yeah, food sounds, there for a number of reasons, food is not only is it not nutritious anymore, but the picture you just painted with the antibiotics and the stress of the animals, just it's enough to put anybody off certainly eating out at a restaurant. And a strong motivation for growing one's own food, perhaps,
I think that's really the answer, Nigel. I think that's the answer, is if we return to just where we were just a generation back, we don't have to go back to the paleo diet or anything like that. We just need to go back to the 1950s. In 1950s, right at the end of World War II, the Allied countries were growing 45% of their food chain in their backyard victory gardens.
Yes.
45% of their food. We grow less than 1,000th of a percent. Like, we are down to 1/10 of 1% of the food chain being grown in our own garden. So we just disengaged from that whole connection to nature, and we've had the consequences in human health that we've seen. You said something interesting, is that not only so the antibiotics in and of themselves are killing bacteria. The bacteria, of course, would be that life form that would feed the plants the nutrients that we would then eat, which again aren't going to feed our body, they're going to feed our bacteria. And so then our bacteria would take those plants and turn them into usable micronutrients, macronutrients that the human would run on. So now imagine the scenario where you create a food system where you're destroying bacteria at every level. So therefore you can either get the nutrient into the plant or you can get it there into the human body, but you're also spraying for that sick plant. So as the plant becomes weakened from a lack of nutrient in the soil, it becomes vulnerable to disease, right? And so you get pest infestations, you get fungi, you get all these diseases moving in on that unbalanced, unhealthy crop. And so then we start spraying for weeds and pesticides and all of this. The number 1 herbicide on the planet right now is the famous one, Roundup from Monsanto, which went off patent in 2007, and now the majority of it is made in China. It's called glyphosate. Glyphosate is the active ingredient in these weed killers, and it has actually never been patented as a weed killer. It's only been patented as an antibiotic, antifungal, anti-parasite. And so this thing kills single-celled organisms that it touches. It's one of the most potent antibiotics on the planet. And it does that by blocking an enzyme pathway within the bacteria and the plants.
Okay.
That enzyme pathway, it turns out, which is called the shikimate pathway if you want to read more about it, but the shikimate pathway is responsible for making 3 of the most essential amino acids in your body. The amino acids are the 26 building blocks that take your DNA and turn them into the proteins that will build a human body.
Which specifically, which 3, if I can just ask you there, Dr. Zach, which 3?
Yeah, it's phenylalanine, tyrosine, and tryptophan.
Okay.
And so those 3 amino acids are the aromatic ringed amino acids.
Yeah.
And so those 3 are within what we call the essential amino acids. 26 letters in the English alphabet. There's eight of those that are vowels, right? And so the vowels are critical to so many words. So if you subtract a Z from the alphabet, you'll screw up the spelling of my name, but not much else, right? But if you subtract the A, you not only screw up my name, you screw up, a huge percentage of the words that could be possibly spelled. So the vowels within the amino acid family are what we call the essential amino acids. These guys are used all over the place, and they can't be made by the human body. And so these are the ones that are essential to our diet. And yet we're spraying our food and our soils with a chemical that blocks the ability of those plants to make those essential amino acids. We're literally birthing children that have, as embryos, been short a few letters in the alphabet because the food that mom is eating no longer delivers an adequate amount of these building blocks. We are building incomplete bodies. And then once you're born, you have to rebirth every 3 to 5 days. Things like your gut lining turns over every 3 days. Your liver's constantly in massive turnover. And so you're rebirthing your body all the time. And so if you're in an environment where you don't have the essential building blocks, you're going to keep building an incomplete function, an incomplete biology around your DNA.
Deficiency there, yeah, sure.
It goes deeper than that. It turns out that I'm not trying to depress the hell out of your audience here, but it's just our movement forward. This does get better in a few minutes, right? But we're going to give you some solutions to the problem because nature always knows, I think, and predicts the insanity of humans. Else they wouldn't have let us show up at all. But the humans here are really, we're on a march so far away from nature's health for us, and glyphosate, or this Roundup chemical that we're spraying all of our food with, by the way, the amount is disgusting. It's 4.5 billion pounds of this chemical sprayed each year now.
Jeez.
And so 4.5 billion pounds of anything sounds ridiculous, but a chemical that blocks the nutrient and destroys the bacteria within our soils and within our gut, that's just extraordinary. I mean, what a mistake as a human species to decimate the very environment. We don't bite the hand that feeds you. Well, we're killing the hand that feeds us. We're just slaughtering this environment. And so the children that are running around behind you there, and these kids that are there, I love having them in our environment. They are, desperately needing the unplugging. The fact that you're shooting this from a yurt is so exciting for me. Like, my gosh, if we can just all get off that grid and plug back into breathing real air that's conditioned by the fire that you have behind you, rather than, forced heating air through filter systems and everything else. The environment in a typical building is so unusual, so abnormal. So we're talking about this glyphosate chemical being sprayed and the shikimate pathway being blocked. The shikimate pathway doesn't only make the amino acids. It turns out that it's also the pathway for something that we call the alkaloids. And the alkaloids are the medicinal properties of the food itself.
Okay. So
coming out of the cancer field that I was in, the chemotherapies that we made and have been made for decades are largely drawn from alkaloids that are made by plants.
Okay.
And then in the 1970s, we developed Roundup, and we started spraying the world with Roundup. And it, of course, got out of control in the 1990s. 1996 is when we developed the genetically modified crop that was Roundup ready, so we could actually spray our food with that without killing the corn or the soybean or the beet or whatever it is. that genetic modification allowed us to start ingesting an enormous amount of this. Well, now with that ingestion, not only the bacteria in the soil that would feed the plants and the plants themselves that have shikimate pathway, and the bacteria within our gut. So at 3 levels, the shikimate pathway being blocked, we can't make the alkaloids. And so now you take something like the natural alkaloids that would be in your superfoods like kale and Brussels sprouts. They have the alkaloids that would function to kill cancer. Instead, we've just deleted those from the food industry. You remember the age-old thing that's been, kind of attributed to Hippocrates, which is "Thy food be thy medicine."
Yeah.
That 4,000 years before Hippocrates, some 6,000 years ago, the Chinese medicine doctors were saying the same thing. So I don't think Hippocrates came up with that, but it goes to say that for 6,000 years of medicine, we've been recognizing that the food is the source of the medicine, and now we know that's literally true. The alkaloids within the food are the things that would prevent and heal disease.
Wow, so the alkaloids are prevented from being made by this disruption of the shikimate pathway, is that right?
That's exactly right. And so what do the alkaloids do? Well, there are alkaloids that prevent diabetes. There's alkaloids that prevent hypertension. There's alkaloids that prevent major depression. There's alkaloids that prevent attention deficit and autism. There's alkaloids that prevent seizure disorder. There's alkaloids that prevent heart attacks and strokes. There's alkaloids that prevent the movement of vascular disease. What would happen to the population if we subtracted out the alkaloids by treating all of their food with a chemical that would block the shikimate pathway? Well, there would be an epidemic in autism, heart disease, cancer,
diabetes,
movement disorders, dementias, hypertension, heart attacks, diabetes, obesity. Oh, that's actually, wow.
That's where we're at.
Really? That's what we did? That's what we did. It's an amazing story of chemicalization of nature. And so, of course, interestingly, a perfect business model is that Monsanto is owned by the pharmaceutical industry. And so if you now take out the pharmaceutical property of food, you take away that medicinal quality that's existed since the beginning of human time, you develop all this disease in the industry, then the human, like the farmer, has to turn to the chemical industry to say, we've got sickness, what do we do? And the chemical industry says, no problem, we'll give you back some chemical.
Okay.
Well, it turns out that vincristine is one of the most common chemotherapies on the market. Vincristine is an alkaloid made by algae and other green life forms.
Okay.
And so we've sprayed our crops so they can't make the vincristine from the alkaloid pathways through the shikimate enzyme pathway, and then we produce it in these vats of liquid where we grow the algae and all of this. And so we grow the plants in concentration, not treated with Roundup, so that we can make the vincristine. Vincristine currently is worth $28,000 per gram.
Wow.
It's many-fold greater in value than gold.
Wow, that is amazing.
That's amazing. We've literally created wealth for the pharmaceutical industry by just subtracting those very building blocks of health and medicine
from out of the food
itself.
That is shocking, isn't it? That is just I didn't realise that there's a few factors tying there together in my own mind there. I'd grasped the fact that glyphosate, being an antibiotic, obviously is doing a lot of problems, is doing a lot of destruction there, not only in our gut, killing the bacteria, but killing the bacteria in the soil. But this shikimate pathway and these alkaloids, that's just amazing. That's shocking.
It's an extraordinary journey.
Yeah. So that's obviously contributed to this epidemic in all these diseases that you've mentioned. How do we sort of tie in the relevance of gut health here? Because I know you've done a lot of research as well, and I'm sure you're probably coming on to tell us anyway about the fact that you studied chemotherapy and then you noticed something that looked like chemotherapy in the soil. I don't know. Do you want to pick it up there or?
Sure, that's good. Yeah. So, at this time, now we're talking pretty recent, 2012. In 2012, I had left academia. I had left my research behind. Academia was really collapsing in the United States at that time. We had a massive recession, as you likely recall, in 2008, 2010, the collapse of the whole housing industry and everything else, and that recession had a huge impact on academia. Our university actually lost our funding from the National Institutes of Health that had been in place since 1969. So it was the worst kind of loss of funding in academia that we'd seen in 50 years. And so our Department of Endocrinology went from 70 some faculty down to 20 some faculty in just a year or two. So we went from one of the largest endocrine faculties in the world to almost non-existent so quickly. And it was just this collapse of that funding environment that forced this stress on the system. And that actually was the greatest gift that's ever happened to my career, because it forced me to jump out of that academic environment. I had had a lot of frustrations about academia for sure since the beginning. Even in medical school, I was running reform efforts to reform the curriculum of teaching doctors, and I was really passionate about the reformation of it, and realized over the course of 17 years in academia that you can't actually reform from within the system. Like, once the Titanic is sinking, it's too late to assemble the engineers to fix the ship as it goes down. So I kind of had really given up on that. And then the death nail is when I tried to start a nutrition clinic at the university with one other faculty member, and our biggest roadblocks to starting a nutrition clinic were the dietitians at the hospital. And so it was like, and once it got to that level of almost complete idiocy, I realized I couldn't pursue what I really was starting to feel like was the truth, which is nutrition's got the answer. So I jumped at it in 2010 and started a community health center where we were teaching intense nutrition programs to help heal chronic conditions. And at this point, I didn't know any of the story that I just shared with you. This has all emerged in the last 5-7 years. At that time, I was starting to really dive into literature that had come out in the 1970s and 80s around nutrition and how it could help heal things, specifically plant-based foods, how they could heal everything from cancer to heart disease and everything else. And we didn't know it then, but it is, of course, because of the alkaloids that were in that food. And so I started to apply this incredible science body from the 1970s to my patient population. And about 20 to 30% of our patients were getting a kick. They would start to improve. They'd see their diabetes going away, or their cancer health would improve, or whatever it was. But then there was a huge part that were just stuck. They wouldn't respond at all. And then there was a significant chunk that were actually getting worse on health food. And it was that group that really started forcing us down this question pathway of, is the food different? Has something happened to the food? And that's where this story that I just shared with you started to unfold. But in that journey, we were looking through soil science, starting to ask, well, maybe the food isn't healthy because the soil isn't healthy. And on page 40 of this huge white paper that one of my colleagues brought in was a picture of a molecule that, like you alluded to, looked a lot like, in its three-dimensional structure, some of the chemotherapy compounds I'd been working with from vitamin A. And it was a sudden realization of, wow, in the pharmaceutical industry and my academic mindset, I had been looking to the plants for all kinds of secrets of chemotherapy, and it was a huge shift for me to think, oh my gosh, maybe the soil is where the real root of health and medicinal quality of our plants comes from. And then when we found out a couple weeks later that molecule that we had found was being made by bacteria and fungi, it was this huge aha moment, because the chemotherapy I'd been working with was modifying the mitochondria inside of our cells to induce apoptosis or programmed cell suicide within the cancer cells. Well, it turns out that bacteria and fungi don't have mitochondria. Single-celled organisms don't have these little power generation plants that make the communication network for the human cell. Suddenly realized, of course, bacteria and fungi don't have the mitochondria, so they would have to develop their own mechanisms of cell-cell communication to govern everything from programmed cell death and suicide to prevent cancer, to reactive oxygen communication to bring in immune system for the plants, all this stuff. And so what we kind of uncovered in that moment was, wow, there's this massive communication network being produced by the plants, the fungi, the bacteria that regulate biology outside of the human environment. And this started to immediately answer these bizarre questions of, okay, if UCLA and UCSF are seeing that the bacteria and their patterns are predicting human cancers, we hadn't figured out why. How is it that some bacterial population could shift and then the human gets cancer? While we had made the correlation, the causation had not been figured out. And so in this moment, it kind of completed the loop for me of like, oh my gosh, this is it. So my chemotherapy was actually just, a piece of the puzzle that was kind of inside the human cell, but outside that cell is this huge governing system of the bacteria and fungi that's producing the network of information that will help coordinate cell-cell repair, cell-cell protection, cell-cell death if needed, if you've got a cancer cell, all of these different mechanisms. And so that was the incredible aha moment, and now it's taken us the last 5 years to even start to scratch the surface of this incredible truth. I can share, a few of those pieces of it, but first I want to start maybe with the thought of, even at this point in my trajectory, I didn't know what gut health was. Like, if you go to any textbook on gastroenterology or whatever, you can't find a definition that says this is gut health. What is a healthy gut? There's no definition of it. And so I was teaching nutrition as if I knew something, and then suddenly realized I don't even know what this means. I don't even know what the fundamentals are. So we've been working on that to really define what is the definition of gut health. And we've come down to a few really important pieces of that. Number one is you need diversity in the microbiome. If you have a narrow microbiome, if you've taken antibiotics or you've spent any time in a hospital setting, your microbiome becomes very narrow very quickly. Or if you eat in an environment where your food is impregnated with antibiotic all the time, your microbiome is shrinking constantly. So we now know that that's disaster number one.
Can I just interrupt you there, Dr. Bush, just for a moment? What sort of percentage of the microbiome is being destroyed? If you do a lot of the time over here in the UK, you might get a course of a week's antibiotics if you go in for a cold or something. I remember once having an ear infection where I had 4 different antibiotics that ran consecutively for a week. What sort of knockdown are we experiencing in the diversity of the gut and with a course of antibiotics? Can you shed any light on that?
That's probably a frightening answer, and I would say that we haven't even begun to answer that entirely. But I would venture a guess that we're, depending on which antibiotic you go on, you're going to impact somewhere between 60 and 90% of your population that day. And so you shrink that population immediately, and then you have to slowly rebuild this population. And so this is where the philosophy or the kind of pseudoscience of probiotics came in. Is that, okay, bacteria are good, we need more bacteria. And that was a huge important leap forward for us to stop thinking we just needed to kill all the bacteria on the planet. And so, of course, this consumer figured this out in the 1970s, and it took not until like 2010 that the doctors started to really embrace some use of the probiotics. So they were about 40 years late. But if we take a look at the probiotic industry, we realize, well, that's not a solution to gut health. I mean, a probiotic has 3 species or 7 species at incredible copies. And so when you pick up a bottle of probiotics and it says 35 billion bacteria, well, what you're looking at, 35 billion colony-forming units of the same bacteria. And so that's not diversity, it's just number, it's sheer number. And so while that might help you for a moment kind of get a step up after an antibiotic course to say, okay, well, let me hammer my gut with some good bacteria, 3 species, 7 species of good bacteria. The typical human gut should really be carrying somewhere between 40,000 and 100,000 different species. And that's just of bacteria. We're probably up in the millions of fungi. The fungal kingdom is massive. There's 5 million species of fungi. Wow. It's unimaginably complex. We haven't even begun to really tease out the complexity of that ecosystem. So we know that we're supposed to have, tens of thousands of bacterial species, hundreds of thousands, if not millions of species of fungi, all living in this complex ecosystem that would look something like a coral reef or a jungle in South America. These huge, diversities. And so if you're taking probiotics every day, you're actually doing something very akin to the antibiotic, which is narrowing your species diversity by, adding billions of copies of the same 3 species every day. And so that's not gut health, but gut health is definitely, number one, that bacterial fungal ecosystem healthy. Number two is then the barrier system between the bacteria and your immune system. Some 60 to 80% of the immune system of the human body lies just deep right behind this cellophane-like thin layer of membrane, gut membrane, that runs from your sinuses all the way to your rectum. That protection support system is extremely vulnerable, especially if the bacteria and fungi are missing. And so if the bacteria and fungi are not there to decontaminate your food, if you start to lose the bacteria and fungi and you lose their detoxification kind of mechanisms, you start to become very vulnerable at this membrane. The membrane is made up of billions and billions of tiny little cells, but it's only one cell layer thick. Contrast that to the skin. The skin has 30 to 50 layers of cells that are piled up on top of each other, so they're a pretty good defense mechanism. They're always sloughing off and you're always making more, but you've got many, many layers of skin. In contrast, the gut membrane is one cell layer thick, which is half the width of a human hair. So pluck a human hair, imagine slicing that in half, and you've got this tiny thin cellophane layer that covers 2 tennis courts in surface area. Massive system, and that's your vulnerable membrane, and right behind that is your immune system. And so gut health definition number one is a diverse microbiome. Gut health number two is how tight is that membrane held together. Those tiny little microscopic individual cells are useless as a protection if they're not all connected into a single carpet. And what connects them is these little proteins called tight junctions. The tight junctions are then joined by gap junctions that are like fiber optic cables that run between the cells. So the tight junctions are watertight structures that are like Velcro that hold the cells together, and then the gap junctions are the communication stream behind those tight junctions. So now, if you've got good tight junctions and good gap junctions, you have one organism called the gut lining. It's one system, all in communication. Now here's the extraordinary third part, is that the immune system itself, 60 to 70% lying right behind that membrane, makes 80% of the antibodies in your system. It's right there to be your front line of defense. And so those are kind of your 3 steps to gut health. Profound microbiome diversity, profound integrity or tightness of that membrane, and then a really robust anti-inflammatory attack system that makes all your antioxidant reservoir with glutathione and all this produced in that gut lining and the immune system behind it. So those are the 3 categories that we've kind of boiled down. What is gut health? Good bacteria, good protective membrane, and a great immune system behind it. So now let's go back to glyphosate. This is the chemical in Roundup. This weed killer that is now 4.5 billion pounds dumped into the soils of the planet. That single compound destroys all 3. And let me tell you why. And so number one, it functions as an antibiotic, as we've been talking. It functions as an antifungal. So it's decimating the microbiome before you ever get that food to the gut lining. Number 2, we were the first lab to really tease out the mechanism by which that glyphosate chemical is destroying the Velcro between the cells that make up your gut lining. That tight junction membrane is decimated by Roundup directly. And so this is the first evidence that we've had that's really different than what Monsanto and the chemical companies have been telling us. They've literally been saying this is so healthy and safe for humans because they don't have the shikimate pathway. Because humans don't have that enzyme pathway, which is the target of the drug or the chemical, must be safe. Well, they're right. That specific target within the human system isn't present, but what they weren't looking at is this huge extracellular matrix of the human system to find out there's off-target damage being done from not at the shikimate pathway, but down at this tight junction extracellular matrix that holds our cells into a cohesive body.
So you've actually proven then that the impact of glyphosate in the gut is the disintegration of the tight junctions. I mean that's a it's conclusive proof, is there? I mean,
we have definitely demonstrated that in spades. We published a couple papers on this in the last 2 years, and so you can find those on our website if you want to see those peer-reviewed journal articles. But We're now publishing one that now shows the mechanism by which that happens.
Okay, that was going to be my next question. Actually, I was just is it something that we just take a couple of sentences to how that actually happens? Is it a simple process? Is it how does it actually happen? The breaking apart of the glyphosate?
Yeah, so there's two direct mechanisms. One is the induction of an injury with a peptide called zonulin. When the chemicals are introduced to the gut lining, zonulin is produced by the intestinal lining. And the intestinal lining then produces too much of this zonulin in reaction to the glyphosate, and the zonulin then breaks down this pathway. But probably more importantly than the zonulin pathway, it looks like there's a hypoxic injury that happens. So the glyphosate chemicals destroying the ability of oxygen to get into those gut lining cells, and you're getting a damage response from a lack of oxygen within the cell. And so that hypoxia is probably a bigger issue than even the zonulin pathway. Interestingly, this happens to be the mechanism of gluten sensitivity. You've heard of gluten sensitivity because now all of us are 1 degree of separation. Either ourselves or somebody we know or love or in our family has gluten sensitivity or the autoimmune disease, which is celiac disease. It turns out that when glyphosate induces this hypoxic injury, a receptor is expressed that binds gliadin, which is the breakdown of gluten, to cause that zonulin-induced leak of the gut membrane.
Okay.
And so if you don't have the glyphosate, then you don't express much of the receptor for the gluten at all. But if you've got food that's constantly inundated with the glyphosate chemical, then we're sensitizing our gut to express these receptors that will then turn gluten into a toxin for our gut lining and cause leaky gut, leaky brain, all of that. And so through these different mechanisms, glyphosate's first an antibiotic destroying the microbiome, and second decimating that 2 tennis court surface area, and third, it looks like by destroying the bacteria, we're finding out that the immune system can no longer make glutathione, which is the main antioxidant that supports the acute inflammatory reaction. Acute inflammation always makes us stronger, not weaker. Longevity, I believe, is really tied to our ability to have an acute inflammatory reaction. But if you have lots and lots of injuries happening so fast that you can't mount an antioxidant balance, yin-yang effect to that acute inflammatory response, you start to tip into chronic inflammation. And chronic inflammation, we know, is the root of all human chronic disease. And so it's that shift from acute inflammation, loss of the production of antioxidant within the system, and suddenly you tumble into acute inflammation. And what we're showing is that the bacteria, the fungi, the microRNA from them, and their redox signaling stuff is governing our ability to make glutathione. So all of that said, you've got 3 pieces of the puzzle here that are regulated by our environment and the bacteria and fungi in it. Number 1, the biodiversity of our ecosystem around us and in us. Number 2, the integrity of that gut membrane. Number 3, the ability of the immune system to make this antioxidant reservoir. So that's all in kind of the backdrop of bad news of human behavior over the last 40 years. The good news, and it's just so humbling, is that Mother Nature and this incredible earth that we live on had the grace and the foresight to plant in ancient soil an antidote to this problem that we've created with Roundup. And that antidote is these carbon-based molecules that we found in 2012 that looked like the medicines that I was managing. It's that medicinal quality in the food that was made by a microbiome that was more complex than anything we can imagine on the surface of the earth today. 50 million years ago, when the dinosaurs were kind of teeming on the earth, some 50, 60 million years ago, there was a microbiome soil environment that simply doesn't exist today. If you go back in the fossil record, we can find fossil layers of soil some 8 feet thick that were massive biomes of fungi and bacteria that supported plant life that would support something as large as a Brontosaurus or Allosaurus. These huge plant-eating dinosaurs had heads that were about the size of a horse's head. And so they were capable of eating about the same volume a horse would eat. And yet their plant life that they were consuming was so nutrient dense that they were able to support bodies that were 8, 10, 12, 20 times larger than a horse. And so you got these massive biologies living on this rich plant life that's growing out of soils that were so deep and rich in microbiome, fungi, bacteria, that just were thriving. Then the dinosaurs, you remember, extincted when we had this some sort of astrologic event. Probably it was probably a meteor that hit or something like that covered the Earth suddenly in this layer of dust. And that thick layer of dust killed much of the topsoil microbiome by eliminating the sun and the oxygenation of the soil. And so at that moment we lost a huge amount of microbiome intelligence. And so as we go back in the fossil record, we can find a diversity of these carbon molecules. Each species of fungi and bacteria seem to make their own subset of these little molecules of communication. And so what we're doing now is we're extracting that communication network out of 50 million year old soil here in the United States, and then from that we're taking it into our labs and we're putting it through mineral baths to get the catalyst effect, to get these oxygen hydrogen binding back alive again. Because the key to these communication networks that are made by mitochondria and bacteria is hydrogen and oxygen exchange, the exchange of electrons through those two critical elements of oxygen and hydrogen. And so that electrical exchange, or that electron exchange, is what we then balance out in our labs, and then we put that into our patients. And so it started in 2012. My son and I were making each bottle, and then it progressed from there. But now we have a busy pharmaceutical grade line that makes this stuff all day long. But the journey has been so fascinating to see that if you put this 50 million year old information network into a human system, it changes everything we understand about biology. Because everything that I ever studied in cancer, and I had a great lab. The lab I was in was studying glioblastomas, the brain tumors, and we were working with breast cancer groups and all this stuff. All this, millions and millions and millions, even in our small group, is hundreds of millions of dollars of research being done. And all of that was being done in sterile petri dishes. Same thing with the cardiovascular guys. Same thing with the Alzheimer's studies. Everybody is studying human disease in a sterile petri dish, not realizing that disease and health is not regulated within the human cell. It's regulated by the microbiome outside that cell. Wow. And so it's been so fun to look under the microscope. And the cool thing about this product is it's sterile, which means that you're not going to kill the microbiome or the petri dish. If you put bacteria into a petri dish of breast cancer cells, well, the bacteria just take over, all the cancer cells die. This allows us to study the relationship between the communication network coming out of the shikimate pathway of the bacteria and the fungi and everything else. What does that do when you're in that human cell environment? What does it do to the human cell? And we just see this eloquent story of regeneration start in cell cultures that have never been thriving and healthy. We can grow renal tubule cells, the kidney cells that are the most vulnerable in the whole human body. We can grow this in this liquid of this communication network, and it extends their life beyond anything we've ever been able to do in a petri dish. But the most amazing thing is it takes them from individual cells to the point where they start making tight junctions and gap junctions, and they start communicating as a whole organism in a petri dish.
Wow, that's amazing.
And that's the hallmark. That's the opposite of cancer. Cancer is the process of loneliness at the cell level. You can't get a cancer cell unless it's been completely isolated from all of the other cells around it. If it stays in touch with the environment around it, it's not going to let itself become a cancer cell. It's going to kill itself, realizing that it's a problem, it's damaged, needs to be replaced. Mm-hmm. But if you totally isolate a cell, it just knows that life is important, and it starts to replicate. It's a very damaged, lonely cell now, and its only solution now to survive is to keep replicating, and so it then turns into a tumor that can then, depending on its aggressiveness, can turn into a fatal cancer.
So it's a lack of communication on a cellular level that is resulting in cancer. Is that what you're saying there?
Precisely, and not just cancer. Any chronic inflammatory condition is literally a loss of communication.
Okay, Dr. Bush, can I just wind back just a little bit there? You mentioned that chronic inflammation. You said we know that chronic inflammation is the root of all disease. I'm not sure whether those are your words. Correct me if I'm wrong. How do we know that? And does this do all these other allopathic doctors not yet know that? Why isn't the world waking up to this, or are we just at the beginning of a process where it is? How do we know that inflammation is the root of all disease?
Actually, the allopathic doctors do know that one. They understand that this chronic inflammatory underpinning is really the mechanisms of it. And I mean, if you walk into a doctor's office, they may not be able to like deliver that right off the top of their head. But if you kind of push a little bit, you'll find out, yes, they understand that chronic inflammation is really the cause of diabetes or major depression or whatever it is.
So that's not in dispute then?
No, that's been around for 20, 30 years.
Okay.
And that's frankly why we have, a $500 billion a year anti-inflammatory market in the pharmaceutical industry, right?
Course,
we sell anti-inflammatories for the very understanding that that's kind of, getting at the root of some of the symptoms that we see around us. And so we ibuprofen, Motrin, all these non-steroidal anti-inflammatories, and then you get into the steroidals, prednisone and all these things that are thrown on as kind of, if the doctor doesn't know what's going on, if you walk in with a mystery diagnosis, chances are they're going to give you prednisone. Because if you've got some kind of rheumatoid condition or allergic condition, they don't know what the hell's going on. They just know if they throw a blanket on inflammation, your system will have a chance to recover a bit.
Okay, so and how is it then that these molecules that you discovered in ancient soil, how is it? How do they deal with the inflammation? Is that what they're doing? Would you say that's?
Yeah, exactly. So they do it on 3 different levels. Number one, they're the communication network of the ecosystem. And so they actually are the mechanism, we believe, by which the bacteria and fungi are communicating together to say, oh, I'm deficient in these species over here, bring those in. Oh, I've got way too many of this species here, bring that back down, let the biodiversity come back in. So the balance of the ecosystem itself, which is extraordinary. How does 5 million species of fungi live with hundreds of thousands of species of bacteria, with probably billions of species of viruses? We now know that there's 10 to the 31, a 1 with 31 zeros after it, viruses on the planet. That's 10 million times more viruses than our stars in the entire universe. There is so much microbiome around you that it's amazing that you're allowed to be here. You are a speck in this vast ecosystem around you. And so that's this environment. So number one, the communication network that we're now putting back into the human system is that balancing act between the bacteria, the fungi, and everything else. It's not an antibiotic, it's not an antifungal, and it's not any antiviral. Instead, what we see is, you can put this into a patient that's been struggling with, overgrowth of their bowel flora. They'll get the weeds growing, yeast and other things growing in their system, and they're suffering all these health consequences. Their doctor keeps telling them, oh, you've just got yeast overgrowth, you need an antifungal, or you've got small bowel overgrowth, you need antibiotic. Well, that's just fueling the problem. If there's overgrowth of a few species, that's symptomatic to a lack of this communication network, the lack of the coordination of a larger ecosystem. And so we've seen people with 20, 40 years of problems of overgrowth go on a sterile product that has no probiotic in it, has no bacteria and fungi, and within 3 months they've got a gut that's never been so balanced. And so number one, it's the communication network within the ecosystem. Number two, we get to see this magic of human regeneration. So when you put this stuff into a petri dish of human cells, everything goes into this regenerative process. We see a huge upregulation of the production of proteins from the DNA within the human cell. And one of those proteins is the tight junctions of the gut lining. And so we've shown that within minutes of putting this into a gut lining of small intestine or colon, you see an upregulation of the production of ZO1, or the protein that makes the tight junction.
Wow.
And so it's so cool to realize that the bacteria and fungi can regulate within seconds, and there's no microRNA in this either. This is actually just the raw redox communication. Redox are the positive, negative charged compounds of oxygen-hydrogen exchange. It's this liquid circuit board of information that is inducing the human cells to hurry up and make a stronger gut lining, or we put it into kidney tubules and we see them coming together as single tubules rather than single lonely isolated cells. And so we see this huge cooperative effect happening as the communication network goes back into play. And so then we see this resilience to that gut lining, where we can now expose that gut lining to 20,000 times the amount you would see in your food, and you continue to make such tight junctions that there is no damage to that membrane. And so that kind of extraordinary regenerative effect of the human system is being programmed by this communication network that it's non-human. Finally, the immune system that we talked about, that third level of gut health, we've now shown that as soon as this stuff goes and touches the gut lining, there's an 800-fold increase in glutathione, the antioxidant production. And so it's regenerating the antioxidant kind of reservoir that's going to help you stay in an acute inflammatory response system instead of sliding into that chronic inflammatory state.
Wow.
So at each step of gut health, the microbiome, the gut membrane protection, and the immune system and its acute inflammatory antioxidant system behind it is all being regulated by this non-human communication network that we're drawing out of 50 million year old soil.
Gosh.
And so here's Mother Earth. We're spraying 4.5 billion pounds of a chemical to kill the communication network and microbiome of her soils. And she planted 50 million years ago an antidote that would fix that problem. It's so humbling. You look at that story of Mother Earth predicting our insanity and giving us the medicinal solutions, and then you think of the microbiome itself. That microbiome is letting you live within it. It's so diverse, it so outnumbers you that there's no way that you, as a tough human being, came into the system. You are so vulnerable as a human being. You are almost non-existent genomically on this planet.
Staggering.
And so in that moment, we have to do what your podcast is all about. We have to unplug from the matrix. We have to get out of the mentality that as humans, we have to kill all the germs around us.
Yeah.
We have to kill the bacteria. We have to be on antibiotics. We have to use antibiotic, hand junk. We have to, be afraid of viruses. We need to immunize our kids from viruses. There are so many viruses around your children. If the viruses wanted to kill the children, they would have never been here. The viruses want your children to thrive, else we wouldn't be here. And so we need to stop this kind of war mentality on the ecosystem, and we're going to heal. And of course, we have to do the same thing on the macro level, right? We need to stop thinking that we are an isolated country of the United States or England or XYZ or Russia. We need to realize we're all part of a single organism called humanity, and we need to stop the warlike mindset. We need to start having an abundance mindset where the more bacteria, the more fungi, the more life around us that we support, the more diversity we have in the microbiome can support human life, so that we can actually reach outside of ourselves then and say, well, the more diversity we can have in our community with, let's get the, people from every color and race and creed to come together and share their microRNA, because we'll be more intelligent at the micro level, which will make us more intelligent at the macro level, socially responsible, ethically, morally,
sure,
politically. All of them are tied together.
Better communication always helps human interactions, doesn't it?
It's exactly the same thing. So I told you that chronic inflammation is the loss of communication at the cell level. Well, isn't inflammatory rhetoric or inflammatory politics also the breakdown in communication?
Absolutely. Dr. Zach, could you just thrash out a little bit more of this loss of cellular communication and the way the immune system normally combats disease? People are familiar with taking antioxidants, and they've been hyped for decades, as we know, and this sort of positive accumulation of charge. How does the chronic inflammation, how does that sort of build up, and why does that block us from being healthy?
Very good. Yeah. So the story of cell-cell communication is so early in its progression, but basically what it looks like is that picture a house here in some ways. Like on a house, you've got shingles on the roof, you got tar paper under that, you got a plywood roof, you got studs and beams that hold up that roof, you've got walls with barrier systems around it of insulation, and then you've got boarding or siding on the side of the house or brick or something. And then you've got landscaping around it, and you've got a yard, and you've got this whole thing. So that's the human body in a nutshell. Is you got all these different parts, and if you've got a well-built house, storms can come, rain can dump, snow can dump, everything stays in this kind of regulatory state, and you can function because everything's protected. Cell-cell communication allows each of those things, the shingles, the windows, the doors, to keep their identity intact.
Okay.
As you start to lose cell-cell communication, the cells literally start to lose their identity. they start to forget that they're part of a house, and they start to think that, well, the only thing that's important is that I survive as a shingle. And that kind of mentality at the cell level, where it's shrinking down its worldview to become just one thing instead of a cooperative, massive thing. So cell-cell communication is happening. Let me give you 3 levels of it. Number 1 is this redox signaling environment, where it's oxygen-hydrogen exchange of electrons. This is literally electrical energy flowing over a surface. This can happen in a lot of different environments. For the microbiome in your gut, it turns out the microbiome produces these little layers of liquid, and we call these biofilms. And the biofilm that is produced by the microbiome allows electrical charge to be trafficked across long distances across that. So a single bacteria is tiny, even compared to the epithelial cell of the gut lining. So these tiny little microorganisms, they sense a problem, or they sense an opportunity. They need to send signal to their environment to say, hey, here's a nutrient, I need this nutrient addressed, or here's a toxin, needs to be broken down, I need DPP-4 enzymes to come in and break this down. And so the human cell starts making DPP-4, excretes it into the gut, and all this. All of that coordination is being done through electrical charge from potassium, sodium, and its exchange of chloride and hydrogen that will then interact with oxygen differently. And so you can imagine like this electrical circuit board running across the surface of everything. It's this wiring system that says, okay, here's something happening over here, send signal over there and get some information back. Yep. The dietary supplement that we make from this stuff is called Restore. And I think the best kind of description of Restore is a wireless communication network. Think of your cell phone, for example. These cell phones have complex computers in them that have the ability to receive and transmit information to make me communicate with you. However, if I'm more than 7 miles from the closest cell phone tower, this thing is rendered completely useless as a communication device. I can't reach anybody. And so this cell phone, the cell becomes isolated. And in that moment, you've maybe experienced this with your phone, in that moment of isolation, the phone starts to degenerate. My phone, for example, this week, I was traveling a ton, I was on planes, it was off most of the week. Well, the software started to fragment, and my camera stopped working, and a lot of different little funky things started happening to the thing because I was not in communication with the master program. It wasn't getting its information. So it had lost its wireless communication network, got isolated, and its function immediately started to decline. So that's what this communication molecule environment from the bacteria, fungi, and everything else. These redox molecules that we're now putting into these liquid supplements. That is that wireless communication that's going to do this network of communication across. So that's step 1 of cell-cell communication. Step 2 then is once that communication network hits the DNA, it starts making not only proteins, it's making microRNA in response to your environment. So your microRNA, I would say, is probably number 2 most important kind of distribution of information and communication across large systems, and that's one genome talking to another genome, or one strand of DNA in one cell, say in your liver, for example, talking to a DNA strand in your brain to say, okay, at the liver we just saw this compound, I want to transport that to the brain in a few minutes, so the brain, you need to start turning on the enzymes that will take advantage of that neuropeptide that can be integrated into brain chemistry, whatever it is. So that huge second coordination is from the microRNA. Then the third level is I would say the hormones. And so many of the things that we make from the genes are the hormones. And those hormones then can move across the body systems. Cortisol from your adrenal glands, or testosterone from the testes, or estrogen from the ovary, or something like the neurotransmitter / hormones that are made in the brain and pituitary gland. These things regulate function all over distant targets within the body. Then you're familiar with the pheromones that actually exit the body, and they can communicate through the air. And so we excrete airborne pheromones or hormones in the air. And so these are 3 of the major mechanisms of cell-cell communication. Number 1, I would say, is redox signaling. Number 2 is the microRNA and the genomics there. Number 3 would be this endocrine coordination of everything. All of those are going to come back and regulate one really important structure within the human body, which again happens to be non-human, and that's the mitochondria. The mitochondria look like bacteria, and they live inside of our cells. They're many times smaller than bacteria, and their genome is different than the human genome completely. The genome of the mitochondria actually looks like viral DNA. It's a ring rather than the double helix that we have.
Okay.
And so that ring DNA, or viral-looking DNA within the mitochondria, predicts about 37 genes. And so it's a relatively tiny little genome of the mitochondria, but they are extremely critical to human cell life. They produce the energy within our cells. And so when you eat food, the big macronutrients that turn into fuel are going to be sugar and fat, right? And so the glucose and fatty acids ultimately are again useless to the human cell, and they have to be digested by the mitochondria. And so your bacteria are going to eat the food on your plate. They're going to transport glucose and fatty acids back into your system. They also deliver protein, which will then be converted to sugar by your liver. And so your protein and your sugar go to sugar, and your fat goes to fatty acids, and they go and move into the human circulation and ultimately get into a human cell, and then they have to be digested by the mitochondria into the ATP, which is the fuel that your cell runs on. And it turns out those mitochondria are some tenfold more abundant than the bacterial ecosystem. There's probably 1.4 quadrillion bacteria, but there's 14 quadrillion mitochondria in that human system. And so that's the last piece, I guess, of the communication network you're asking about. So we have the redox signaling, we've got the microRNA, and we have hormones that are all feeding back onto the mitochondria to tell the mitochondria to do something with our fuel. And so my field of endocrinology is hormones, and metabolism is mitochondria. Right. And so endocrinology and metabolism as a field is the study of how that hormonal environment regulates the mitochondria. The mitochondria then are really the gatekeeper of life. And I mean that at the literal level. You cannot have life start at a eukaryotic multicellular organism without the mitochondria making energy. They are extremely productive in energy. 1 cubic centimeter in volume of mitochondria produces 10,000 times more energy than 1 cubic centimeter of the surface of the sun.
Wow.
It's more reactive, it's more fuel producing than the nuclear reactor of the sun itself. And so the energy that's coming out of these mitochondria boggles the human mind. Without that level of energy, you don't have human life to begin with. But then it turns out that the redox signaling of oxygen and hydrogen done by the mitochondria, that's governed by the redox signaling of the bacteria and fungi, is really the story of cell repair inside. Now, in my hospice and palliative care practice, I routinely work with patients that are 100, 105 years old.
Gosh.
These patients are interesting to be around because they don't usually have any disease. They're simply, quote unquote, dying of old age. Well, it's interesting to think for a moment that a patient at 105 years old is still a 70 trillion celled organism, and every single one of those cells is equipped with all of the machinery for cell repair. And if the cell is too damaged to repair itself, it can kill itself, call in a stem cell, and replace itself.
Yeah.
The only reason we age is because we are losing communication, and all of the machinery, like your cell phone, all of the machinery is sitting stagnant and it's not doing its work, and so you get this loss of communication, you get this loss of function, and you start to just decline and deteriorate because you're not repairing yourself all the time. That's the magic of taking this communication network back into play in the human system. We suddenly see human cells in petri dishes healing themselves, producing proteins, kicking in stem cell activation, all kinds of different things kicking in because the communication network is back in play again.
Wow. Is it possible to measure this direct effect of this communication network upon the functioning of mitochondria?
Yeah, absolutely.
And can you see I've heard, I don't know if it's correct, but mitochondrial biogenesis, is that stimulated by this network? And I mean, that must have a profound effect, because that suggests that the goal of longevity, obviously, and good health, it sounds like that's very much fed into.
It's the cornerstone.
Wow.
It's the cornerstone of it, is the health of the mitochondria. And the speed at which this communication happens, again, kind of boggles our previous models of human biology. We can do this through something called real-time PCR. It's an assay that allows us in real time to watch the activity of a single protein or a single target within the human cell. we can show production from the mitochondria change within 3 minutes of exposure to the bacterial communication network. And the interesting thing is, for the very first time in biology, we're seeing a communication network induce the opposite response in a damaged cell versus a healthy cell. And so it looks like the bacteria and fungi are making a communication network that, before it even penetrates the human cell, can figure out, is this cell too damaged to live, or does this cell need just repair, or does this cell need to kill itself? It's doing the opposite thing in those two cell populations at the mitochondrial level. The mitochondria within those cells are responding differently to the bacterial communication network, depending on the health or lack of health within the cell.
That's awesomely targeted, isn't it? That sounds, I mean, you couldn't do any targeting better than that, could you, really?
You can't target like this. You can't micromanage a system that's this complicated. And that's our excitement about Restore. This is the first supplement in your grocery store or at your doctor's office that doesn't try to micromanage something. If you take vitamin D, it's trying to micromanage this one cell pathway that has these receptors that will glue onto the vitamin D and activate over 2,000 different genes. Well, you're micromanaging now the system, saying tons of vitamin D, tons of vitamin D, tons of vitamin D. Well, that's actually very abnormal for the human body. You know, the human body makes vitamin D from our skin when we see the sunshine. Obviously, the sun is going to do many, many other things other than just trigger vitamin D receptors. And so when we go to micromanage our bodies with supplements, we're often missing the boat because we're just doing the one thing here, right. CoQ10, vitamin D. These one things are just supporting or micromanaging these, 1/1,000,000,000th of 1% of all of the stuff that should be happening.
Gosh.
And it's why we're seeing poor outcomes. I don't know if you saw the Women's Health Initiative study about 5 years ago, no, more than that now, 7 or 8 years ago, coming out of the U.S. This study showed that women who were taking multivitamins, and these were just USP, kind of your synthetic multivitamins that you would find on the typical shelf of a grocery store, had a 9% increase in death from taking multivitamins. 105,000 women in that study. It was a massive study. 9% increase in death from taking a multivitamin. Gosh. It's because we're trying to micromanage these human bodies through these tiny pathways. In contrast, Restore doesn't do anything. It's literally the most passive thing on the shelf, and yet it supports everything. And that's the really exciting thing about a dietary supplement, that its safety is unparalleled because it's not trying to do anything to the cell. It's just letting the cell hear its own messaging. It's letting a neighbor cell hear what the other guys are saying, and that's an exciting world.
Absolutely. So this communication upgrade, effectively, can that compensate for deficiencies in CoQ10? When our human bodies don't make it so much over the age of 30 or whatever it is, and things like being in northern latitudes where here in England I'm not making much vitamin D at the moment, and I won't be until around about May next year.
That's right.
So should I be, or rather, is there less of a need, as long as the microbiome and the communication system is in place? You seem to be hinting that there's maybe less need for things like supplementing with vitamin D and ubiquinol and things like that.
I think you're exactly right. We already know that some 90% of the enzyme work done in the body is done not by the human cells but by bacteria. The enzymes are what make stuff, right? They're the big machinery that makes cool stuff in the body. And so these enzymes, you think of an enzyme that can produce, active vitamin D from your reservoir of vitamin D and things like that. We're going to find out that the vast majority of those, here's a good example, is vitamin B. And so vitamin B12 is famous in beef, right? The beef industry has been telling us, well, you can't get B12 from vegetables, so you have to eat meat. We were obviously, no, not at all. So it turns out the beef, the cow doesn't make B12. The bacteria in the cow's gut makes B12. So the reason beef has a lot of B12 is because they have a rumen gut that has 4 pouches, and the bacteria therein makes a ton of B12. And so the human gut, it turns out, can make vitamin B12 just like the cow gut can. Wow. And so I have patients that have been vegans since they were born. The Seventh-day Adventist Church is the first church that really kind of, in the late 1800s, started to decide that a vegan lifestyle was the right way to live. And so for 100 years, that church has been raising children in a vegan environment. And I've got Seventh-day Adventists in my clinic because I run a plant-based kind of vegan clinic. And in that setting, I'll check a B12 level in somebody who's never taken a B12 supplement, has never eaten beef, and has B12 levels that are at the highest normal end of the spectrum. And so their bacteria, their gut microbiome is making their nutrients, is making their vitamins, it's making all of the building blocks that you would get off of some supplement shelf. Now, do we take supplements? I do sometimes. So like vitamin D, for example, I'll take that intermittently. So I'll take 10,000 units of vitamin D when I get off an airplane. When I know my body just went under stress and it's wintertime and I haven't seen enough sun, I'll take a big load of vitamin D, but in the non-active form. And so non-active vitamin D is your vitamin D3 that you can see. That's actually a non-active form of the hormone. It has to then go into the human system, and it will get turned into active vitamin D through methylation at a couple of different points. And so that's done by enzymes again. So enzymes within the bacteria or the human environment can turn that into an active vitamin D. And so if you're taking supplements, you don't necessarily have to stop everything, but certainly probiotics are a good example. You don't want to be taking 35 billion copies of the same bacteria every day. So if you feel like you really want a probiotic in your life, which I don't take any, but if you feel like you want, take them intermittently. So maybe once a week, take your probiotic, or a couple times a week at the most. But give your gut the chance to start recuperating ecosystem from much more cool systems, the air around you, rather than a probiotic pill. The air around you should be filled with good bacteria and fungi, and you should be able to repopulate your sinuses and therefore your gut from just breathing the air around you. And so wild fermentation is done through just keeping cabbage or whatever vegetable you've got chopped up in your saltwater brine. Let that absorb the bacteria and fungi from the environment. You're good to go.
Dr. Fish, obviously aware that we're pushing time a little bit here, so we maybe should wrap it up quite soon. But I was just wanting to ask you one quick question, alluding to the causes of inflammation. We've seen how this communication system can deal with it. Beyond things like the gut permeability and dietary measures. Are there things that we can do to avoid inflammation? And perhaps you could allude to that just a little, as well as obviously reinforcing the health of our gut, the diversity and the integrity of that gut lining. What would you say about that, about avoiding the causes of chronic inflammation?
It's such a good endpoint. It turns out that it's the whole secret to human health, as far as I can tell after these years of study and practice, is that it's entirely about your connection to nature. If you want to be healthy, you have got to get out of your house, you've got to get out of your plastic infused car, you've got to get out of the chemical environment that you live in, you've got to plug back into nature. And that will fix all of the communication pieces, and it will absolutely be your most important antioxidant, anti-inflammatory process. Mother Earth itself is covered in a blanket of electrons. There's an electrical sheath all over the planet Earth, and if you with bare feet step on that Earth, immediate antioxidant effect, immediate anti-inflammatory effect. But if you go out there in rubber-soled shoes, you're insulated from that electrical current, and you are not getting that anti-inflammatory effect that the Earth itself, before you even breathe, before you eat, before you do anything, if you're not touching Mother Earth, you are getting inflamed. And so touch Mother Earth. Weed your garden, stand outside barefoot, touch a running stream. The water in a stream flowing past has extraordinary electrical potential. And so the ions from your environment can be absorbed by the human body right through the skin. And then you breathe healthy air, you breathe microbiome, and you get in touch with your garden, and you get your children outside, and you teach them how to grow their food again. We can heal everything. We're only 20 years into this complete collapse of human health. We can just back up some decades. Or wouldn't it be cool if we back up a couple million years to say, what if the whole ecosystem is constantly in communication? What if we start thriving with our Earth, where we produce more clean water than we consume? We produce more healthy oxygen. We clean more carbon dioxide than we produce. All of that is totally within reach. We can do that within one generation if we just change the way we live our lives.
Fantastic. So the product Restore obviously can help us with our gut diversity and integrity, and therefore build the foundation of health. Am I right in understanding though that once you've got a broad enough diversity, once you're up and running, if you like, and you're in touch with your environment, we can get to a situation where we probably don't need any more extra communication network? Would you say that? Can we get to a sort of a self-sustaining point?
That's my hope. Yeah. Yeah, I totally hope so. I think that the steps we're going to need to take to get there is going to stop spraying Roundup. Because as long as we've got this much Roundup in our environment, we've got a problem. So in the U.S. right now, 75% of our rainfall is contaminated with Roundup. 75% of the air we breathe is contaminated with Roundup.
Yeah.
And so we are so inundated with this single chemical that we are killing bacteria all the time. So in the foreseeable future, the next few years, if we stop spraying Roundup today, we've got about 50 years for that to start to come out of the environment to the point where it's non-toxic. So I think we have some decades of cleanup to do, but my hope is absolutely that through the science behind Restore that we make the product itself obsolete by getting the science out there and telling people, look, we got to stop this chemical farming. We need to start growing our own food, whether it's your local farmer, your CSA, or your own backyard. Get re-engaged with your food system, get re-engaged with your nature, and we will fix it to the point where you don't need supplements. You'll just live in nature and you'll be back in touch.
Fantastic. Well, look, I think we should wrap it up there. It's been a fantastic discussion. Dr. Bush, thank you so much for such a wonderfully broad education and helping us to get the big picture of this sort of shift in the health paradigm. Hopefully people will start to appreciate that we need to think outside the box just a little bit, get in touch with our natural environment, as well as eating right, of course, and things like that. If we want health, we've got to look outside the box a little bit there. But
Nigel, thanks so much for having me on. I love it.
Great pleasure. And thank you very much to all of you for listening and indeed watching. And if you got some value out of this discussion, please leave a comment below or with the podcast. And I do hope you'll join me again for another episode of Living Outside the Matrix. Thank you.